Welcome to an introduction to Renesas RX Family Secure Key Injection. This video is the third in a series that introduces the RX Family security features and how to implement them. If you haven't already done so, it is recommended that you watch the RX Family Security Series video covering the RX Family Integrated Security Engines and RX Family Secure Key Storage. Some of the concepts presented in this video assume knowledge of the information covered by that video. As introduced in Volume 2, the RX family supports many use cases for secure key injection, update, and storage. Key injection is the process of getting externally generated keys programmed into the MCU. Stored securely by being wrapped by the device-specific hardware unique key. But how can we do this without exposing the plain text of your user key? Renesas offers a unique method for user key injection. Here is an overview of the process. First, you must create an arbitrary user factory programming key, UFPK, and use that key to encrypt your user key. As we saw in an earlier video, Renesas RX family have a hardware root key. This key is used for secure key injection during production programming. Send your UFPK to the Renesas key wrap service, which will encrypt your UFPK with the hardware root key of the specific MCU group. Now that both your user key and your UFPK are protected and no longer in plain text, use the MCU's programmer interface to write and execute the key injection program. The key injection program uses the MCU's security engine to encrypt the user key and store it in code flash or data flash. If the key injection API is disabled, the key injection functionality will not be available. The security key management tool is used to create a C source file to provide the encrypted user keys required for secure key injection. The created C source file and the sample program RX65N2MB RSKTSIPAES sample included in the RxTSIP driver fit to explain key injection. Security key management tool can be downloaded at the URL shown. The RxTSIP driver fit sample program at the URL shown. Download the RxTSIP driver fit sample program. The first step is to select the MCU MPU and Security Engine on the Overview tab. In this example, we are using RX65N broad, so the MCU MPU and Security Engine are RX family, TSIP. Then, create a key file for the UFPK, which you can do on the Generate UFPK tab of the Security Key Management tool. For this example, we will let the tool create a random value, but optimally it should be a user-generated random value. Click Generate UFPK key file and enter the output file name that you want to generate. As you see, the operation was performed successfully. The Renesas Key Wrap service is available at the URL shown. Register and log into the service. Before you can exchange data with the Key Wrap service, you must perform a PGP key exchange. Send your PGP public key to the Key Wrap service. You will receive the Renesas public key via email. You can now generate the wrapped user factory programming key, WUFPK. Select your target MCU group. We will use the RX65N for this example. Then select the encryption service. Encrypt your UFPK file with the Renesas public key, and send the encrypted file to the Key Wrap service. You will receive the WUFPK via email, encrypted with your public key. Decrypt the file with your private key. Now that you have the WUFPK, you can create a C source file for key injection. Select the Wrap Key tab. We will demonstrate preparing an AES-128 key for injection. Select the key type. Enter the plain text value of the AES-128 key in ASCII in the key data field. Then select the key files containing the UFPK and the WUFPK. Select the output format as C source, enter the file name and key name. Click Generate File. We now have C source files, EUKAES128.c and EUKAES128.h, that we can use to inject the AES keys. Import the sample program RX65N2MB RSKTSIP AES sample included in the RxTSIP driver fit into eSquare Studio. In Renesas eSquare Studio, import the generated C source files, EUKAES128.c and EUKAES128.h, into the user program. Next, generate a Motorola S record file in order to program the executable code. Open the Properties dialog for the project. Select the C++ build settings. Select the Tool Setting tab. Under Converter, select Output. Check Motorola S format file to output Motorola S format files. Build the user program. A .mot file is generated, which is the Motorola S format file for that program. Here's an overview of what happens during the key injection process. The WUFPK and the encrypted key are used in the key injection program. When the key injection program is written to the board MCU and executed, the WUFPK and the encrypted key values are sent to the security engine, which can decrypt the UFPK and decrypt the key, with no plain text key exposure on any CPU or externally accessible bus. The key injection program uses the security engine on the MCU to MCU uniquely encrypt the user key and store it in code flash or data flash. The Renesas Flash Programmer is a software program that is available on the Renesas website at the URL shown. Download and run the installer. To inject the key that we just prepared, launch RFP and create a new project, providing the MCU family and project name and location. Here, we are using RX65N and E2 emulator Lite, so we select the Fine interface. Then click Tool Details. On the Select Tool tab, select Auto Select and set Power Supply to None. On the Reset Settings tab, select Reset Pin as High Z. With this setting, after the program is written to the board, the reset is released and the program is automatically executed. On the Mode Pin Setting tab, select Boot Mode Entry by RFP. Then connect to the target. The ID code for user authentication of the programmer can be set arbitrarily, but the default value is used here. Here we see a successful connection. Now go over to the Operation tab. Enter the MOT file we generated earlier. Click Start to write the program. Here we can see that the program is successfully written to the board MCU. After the program is written, the program is executed and key injection is completed. In the injection program, we use WUFPK and the encrypted user key. When the injection program is written to the board MCU and executed, the WUFPK and the encrypted user key values are sent to the security engine. Since these keys are decrypted and used only within the secure engine, the plain text data of the key does not appear on the CPU or externally accessed bus. Finally, The key injection program stores the MCU uniquely encrypted user key output from the security engine on the MCU in code flash or data flash. The RxTSIP driver fit sample program at the URL shown. Download the RxTSIP driver fit sample program. The instructions for this entire process are described in the RX Trusted Secure IP Driver Fit application note. For more information about Renesas security, visit www.renesas.com/IoT security.